All right, everybody, it's 1 o'clock, so welcome to the Steinel IECC 2015 Solution Guide for Education. I'm Casey Worthington, Senior Marketing Manager here at Steinel USA. Today's call is presented by Logan Neatman. He's our Sales Operations Manager. He's been in building automation and lighting controls for about 10 years, both internationally and in the United States. He has a degree in electrical engineering and has worked on solutions for offices, schools, hospitals, warehouses, and hotels across the country. Now, as questions come up, please type them into the comments, or you can email them to lightingcontrols@steinel.net. If I see a question in the chat window, I'll break in and ask Logan. Or you can wait till the end when we open up the phones and you can ask live. So again, if you have any questions, send them to lightingcontrols@steinel.net or type it into the chat window. And with that, Logan, take it away.
Good afternoon, everyone. I hope so far you've had a wonderful day. We are going to kick off our webinar series today with a review of Steinel solutions for education and schools with compliance with IECC 2015. So what I'm going to do is first I'm going to review different requirements of the code and then which space types they apply to, and then we're going to go into more detail of each main area type and what products go into that area, and then a bit more details. So to start off, the main requirement that the code asks for a kind of lighting controls is to be able to have the lights automatically turn off within 30 minutes of all occupants leaving the space. So this applies to all areas. That's why we need to have occupancy sensors and wall switches with sensors in the area. Of course, there are timers as well, but those are nowadays used mostly for different requirements. The second requirement would be that the lights should be manually turned on or automatically turned on to not more than 50% of power when you enter each area. This applies to classrooms, lecture halls, training rooms, small offices, conference rooms, and places like that. The next requirement is really not a separate requirement. It's kind of an exception to the previous requirement that areas like public corridors, the stairways, restrooms, primary entrance areas to the building and lobbies, or any area that having the lights manually turn on would endanger the safety or security of the room or building occupants should turn on automatically to 100%. So that really applies, like in a school, to public restrooms and to the restrooms and public corridors and lobbies. The next requirement is to have some form of manual override, manual control to allow occupants to turn the lights off. So this applies everywhere, but then again, as we go forward and we'll talk about it, we'll see that some areas this is not really used because of the same safety and security reasons. So you probably won't see a manual override in a restroom. The most important and sort of the challenging requirement of the code is daylight responsive controls, because it has so many factors playing in, and a lot of times it's misunderstood. So the code says in any daylighting zone, which is an area immediately next to any sort of fenestration, which has its own set of rules for calculation and all that. If the total load, general lighting load in that area exceeds 150 watts, you need to have some sort of daylight responsive controls in that area. So this applies to all kind of space types. It's just that as we go ahead and we look into it, we'll see that some space types this doesn't really apply, doesn't really meet the requirements for this daylight responsive controls. And then we have bi-level control, which means in offices, classrooms, and such, daylight responsive controls shall dim the light continuously from full light output to 15% of full light or lower. So this is the
Logan,
main...
a question came in.
Sure.
Is there a preference in the code between manual on and partial auto on?
Not really. It's really the user preference. It either currently is becoming more popular or it will become more popular soon as more and more people will use dimmable fixtures and dimming controls to have partial on, whereas before that dimming fixtures and controls were more expensive. People use manual on. The code doesn't really have any preference. It's just a logical or. So it's up to the application, to the user, or you know, each region's specific requirements that you can go with manual on or partial on. Okay, I will start with the first space type that we will be discussing and how we are, as a Steinel, we are complying with the code requirements. So the main area, the main functional area in all schools and education centers are the classrooms. So the most, we have to make sure that the classrooms meet the code requirements and also function correctly, so we don't have unhappy teachers or unhappy students that are left in darkness, or the lights are or situations that lights won't go off after they leave. The main requirement of the code, which was use of in some form of occupancy sensor, will be complied by having one of our stealing control pro sensors installed in the classroom, so we can comply with the automatic all off. Then again, depending on the preference, that sensor can be set to partial on or manual on to meet the code requirements. We would have momentary switches, at least one by the door and sometimes one by the teacher's desk, by the board, to override the lights and dim them up or down and things like that. And if we have the case that the total wattage of light in the daylighting zone in the classroom exceeds 150 watts, we need to have a daylight responsive control as well. So this daylight responsive control is achieved by using a DIM-24 type of sensor from Steinel to be able to achieve that. So as you can see here, I have the typical classroom, about 30 feet by 30 feet. You can see we have a sensor. We have an IR Quattro HD DIM-24 sensor in the center of the room to provide coverage for the general area. And then we have another sensor of the same type located in the daylighting zone near the windows. And then obviously, because we have two control zones, we have two power packs and a 2-button momentary switch to override the sensors. Now, the main reason for a classroom we go with a PIR sensor, IR Quattro HD, is the problems you will face in a typical classroom and with when using dual tech sensors. If I just go back here, you can see there is a there is a map on the wall, and there might be some artworks and stuff be hanging there from the ceiling, or be hanging on the wall, you know, some of the stuff that kids make, especially in the lower grades. So either if you use a dual tech sensor in this kind of application, what will happen is you will either have the lights turning on in the middle of the night or something whenever the HVAC system kicks in and, you know, moves this, starts moving the map and all those artworks. Or you would have the lights not going off after everyone has left the class, because again, something is still moving in the classroom even though it's not a human presence. So as you can see, we have to have 2 IR Quattro HD DIMM-24s, 2 power packs, and a 2-button momentary switch. Of course, if the requirements of daylight responsive control doesn't apply, you really need 1 sensor, 1 power pack, and a single 1-button momentary switch for this kind of application. So this is, I wouldn't call it the worst case scenario. So this is the most complicated scenario you will have in a classroom, you can say.
Logan, a question comes up about technology when talking about daylight responsive controls. Can you talk a little bit about how the product handles that?
Sure. So as most of you may already know, our Control Pro series, they all come with a built-in photocell. So when you have, and then the DIMM-24 version has the option of constant lighting. What that means is when you're setting up the sensor, you set the sensor to the constant lighting feature. You turn on the constant lighting feature, and then you set the light level that you want to maintain in the classroom, in that daylighting zone. And the sensor, by measuring that the light level that it's seeing in the classroom, will adjust the light level by dimming them up and down to maintain that the light level you have set on the sensor. So it's already built in. You don't really have to have like a dedicated separate photocell to take care of this task. And the next area, which would be, actually, it's a rather easy area. It's private offices and meeting rooms. Here, when we're talking about this part, we're talking about areas smaller than 300 square feet. Because when you go bigger than that, then you probably have multiple zones and stuff like that. So this is the most common case, which is like the nurse's office, principal's office. You have a maximum 300 square feet meeting room or office, and you have to provide the controls. So we will provide, you have to have an occupancy sensor to provide automatic all off for this type of area space. You definitely have to set them to partial on or manual on to meet the code requirements, and you must have some sort of override switch to be able to turn the light, for the user to turn the lights off. As you can see, you probably don't have that many fixtures in these office areas and things like that. So Steinel's solution for this kind of space is a dual tech wall switch with dimming function. The reason for this kind of application we go with a dual tech sensor is, as most of you probably have even right now in front of you, you can see that you're using like 20-something inch monitors that kind of block you completely from any switch that is on the wall. Probably the monitors are sitting between you and the switch. So you need to get around that line of sight issue that you have with PIR sensors. You need a dual tech sensor to see that the room is occupied, even though there are two monitors or two big screens blocking the person in that room. So what we recommend, like the most recommended Steinel solution is using a DTWLS DIMM, or if you want to strictly go with a manual on version, go with a DTVS DIMM. Of course, DTWLS can be set to VS or vice, and also the DTWLS comes set to partial on default from the factory. So either of the solutions will meet all the requirements of the code and will let your let the user dim up and down the lights as well. There's no questions. I can move on, Casey.
Yep.
Okay. The next area, which is kind of it can get complicated because depending on the conditions, you may run into all sorts of the requirements of the code and different sensor technologies. So we are talking about open offices, receptions, lobbies, and these kind of places. As you can see in the photo, you may end up having, floor to ceiling windows that give you a very large daylighting zone. So you obviously have the minimum requirements of having to use occupancy sensor to provide automatic all off. Since these are all open areas, you have to have the sensors all set to automatic full on. So in these areas, we don't have the partial on or manual on. It's one of those exceptions in the code. You may have a momentary switch in the lobby or in the reception area to override the lights, but sometimes like in some applications, you don't see that. You see that they're only using it like in open office areas and not in the reception or lobby. They just really leave it to be occupancy based. And in open office and reception areas, like I said, because of those, like sometimes you have tall windows and you have big areas that have like you're likely to run into that 150 watts general lighting requirement of daylight responsive controls. So this is one of those places that actually you probably will have to do daylight responsive controls. And in the next slide, we will go into a bit more detail with that. So here I've shown a little open office area, kind of. And this here, you will not have the daylight responsive control, but like I said, it can be a bigger open office area and you may end up having it. As a Steinel, we recommend PIR or dual tech dimming sensors for this kind of application. And the reason that we are not giving you like a rule of thumb that just go with this sensor and you'll be fine is sometimes lobbies, reception areas, you have high ceilings, so you cannot use dual tech sensors if the ceiling height is going more than 15 feet. You may have an actual open office area that doesn't have any kind of barriers or partitions or anything. So again, you can go with a IR Quattro HD sensor, or if you, as you can see in this case, that you have some form of cubicle or some partitions, you have to go with a DT Quattro DIMM to provide you the coverage that you are going to lack depending on just line of sight. Again, the same settings as we discussed in the classroom. If you have the daylight responsive control, you have to have a sensor in the daylighting zone and be set to constant on and have its own special settings, and then you would have one or multiple sensors for the general zone. Or if it's a really big open office area, you may have to go with multiple daylighting zones, and really there's no end to how big this area can get and how many sensors and power packs and momentary switches you may need. So this is just a typical one. It's not a fixed rule. Okay, next area that I will be talking about would be corridors. Corridors resemble the lobbies and reception areas quite a bit. The main difference is you probably won't have any daylighting zone in corridors in school. Usually you have walls on both sides, and corridors are really in the middle of the building, not on one side with windows. So you would have to have sensors to provide you automatic all off. Corridors, it's definitely an automatic on situation, so you can't have sensors set to partially on or manual on. Again, providing a momentary or some sort of manual override for corridors and hallways in the school is less common. So, kids don't play around and turn the lights off on each other and cause accidents. And again, in the rare case that you have some windows, you may end up having to have daylight responsive controls. So Steinel, with our Control Pro series, we have two great sensors that are designed and built, manufactured specifically for hallway application, our US hallway and US one-way sensors. They give you great coverage. Again, here I'm showing just one sensor, one power pack, and one momentary switch, but obviously, depending on the length of the corridor or hallway, you may have to have a US one-way to have like a hallway starter, and multiple hallway sensors to cover the whole hallway. Depending on how many zones you have or how many sensors you have, you may have to have multiple power packs, and the momentary overrides, which is again something that we don't run into often in schools for corridors. We also, as a Steinel, we recommend to use the dim version of our US hallway or US one-way sensors. The reason is the dim version gives you an added advantage. So if you use the COM1 or COM2 version, after the timer expires, all the lights just go off. Whereas if you use the dim version, you can set them to after after the main timer expires, either the sensor to keep the lights on at a lower dim level indefinitely, or keep it on for another number of minutes to its lower dim level and then go off. So like if after 15 minutes no one is in the corridor, the lights dim down to 20 or 30%, and then it may stay that way. So if someone comes back in, they're not entering a completely dark corridor. They just, as soon as they are detected by the sensor, the lights go from, let's say, 20 or 30% to 100%. So reduces the risk of, in case someone's not detected or someone just enters and before they are detected, they won't trip on something. So it's a good safety feature that, to avoid any accidents.
Logan, there was a question about a minimum dim percentage. Can you speak to that?
So the minimum dim percentage would be 10%, but on the programming app, but on our smart app. But really the fixture is the deciding factor in these cases on the minimum dimming, because it's the driver of the fixture that decides what is its minimum rating. Like the fixtures I have in my office, I don't remember, I think they don't dim below 25%. So I can set them in the app to 10%, but the fixture won't go below its design design settings. So yeah, in the app you can go to 10%, and if you have the fixture that can do that, obviously you can get 10%. If not, your lights will go to the minimum design of the fixture if you set the sensor to 10%. Next area we're going to talk about, and last area in this webinar, would be restrooms. Restrooms are also actually quite similar to corridors in terms of code requirements and all that. So you would need a occupancy sensor to provide automatic all off. Obviously the sensor should be set to automatic on to make sure there is no safety risks to the occupant. And again, I'm not seeing this quite often in schools, that there would be that there is a momentary some form of override switch for the restrooms, but the code requires it. But I don't know. I mean, I don't see it much on the designs nowadays that anyone's asking for a momentary switch in restrooms that are in the school. So our solution for a multi-stall restroom is using a US Quattro COM2-24 sensor. The reason that we don't go with a dual tech sensor in restroom is that the PIR part of a dual tech sensor does not really give us any advantage here, because you really want to make sure that people who are in the stalls are detected, and those people are definitely out of line of sight of the PIRs. So having a PIR function doesn't give you any added value. So it's best to go with a US Quattro COM2-24 sensor. They would perform great because you don't have any carpets or any kind of padding in the bathroom. So, you know, the sound waves just bounce off the walls everywhere, and you know, that echo would provide you perfect detection. The reason we go with a COM2-24 sensor, or we suggest the use of a COM2-24 sensor in the restrooms, is to have the option of connecting the exhaust fan as well to the lighting control, and then the HVAC output of the COM2 sensor will give you dedicated control of the exhaust fan. So you have your one power pack for the lighting to control all the lights, and you know, you're limited to 30 minutes as per the code. But for the exhaust fan, because you're using the HVAC control output, you can go with a time delay of up to 2 hours. So you can make sure that even though no one is in the restroom, the exhaust fan is still running and, you know, getting rid of all the fumes and everything that's in there that you want to get rid of. This is really a recommendation. It's an added feature. I hope it becomes more popular because it's really a good feature to use, rather than currently that you don't have exhaust fan on the control. So it's not either, I don't know how exactly it works, even if it's not on the controls, maybe on a timer basis or something. If you have a momentary switch, it has to be one button, because you really don't want to override the exhaust fan. You want the exhaust fan to be just really working on occupancy. And again, as I said before, in bathrooms, I'm seeing I don't see an override switch being quite often anymore. It's really auto on, and once everyone leaves, after the timer expires, the light should go off. So yeah, this is the main areas that that we have in the schools. I didn't want to bore everyone and go into each and every type of area that we have, because they kind of fall into one of these main categories that we talked about. So the cafeteria kind of falls into the open office requirements. Gym, same thing. The gymnasium. Bigger meeting rooms fall into, again, same into the category of open office and that kind of application. Smaller bathrooms kind of fall into the category of a small private offices, something like that. So you can always contact us on the phone or on the through email, me directly or our tech support team, to help you if in case of any specific applications. But the rest of the areas are generally fall into the same categories and follow the same rules that I talked about today in this presentation.
All right, thanks. I will start unmuting all of the phones, but in the meantime, there was a question that came in about daylighting. Do private offices and meeting rooms require daylighting, or is that greater than 300 square feet?
Well, the requirement of daylighting or daylight responsive control is not dependent on the size of the room. It's really a function of the load, the lighting load that you have in the daylighting zone of each area. So I'm guessing if you have like very old fixtures that like 2 or 3 of them cross 150 watts, and they are all located in your small office, sure, you have to have daylighting control. But nowadays, a 2x4 LED fixture is a load of less than 40 watts. So in a 300 square feet, unless you want to blind yourself, you don't really have that many of them to pass that 150 watt threshold.
Okay, and there were a couple questions that came in about the recording of the webinar and the availability of these slides later. Yes, both of those will be available by tomorrow, if not today. They will be under the resources section at steinel.net. So the phones are open. If anyone has any questions about anything that Logan has covered, this would be a great time to jump in and ask. Or Logan, did anything come up on the call this morning that might be worth sharing with this group as well?
Well, there was a point that I think I originally wanted to discuss, and both times I think it slipped my mind, is that sometimes in schools that the common areas like hallways and lobbies and these kind of places are required to connect to the building management system, so they have some sort of monitoring of the lighting in those areas as part of the general system. So in those in such cases, you can use our TR150 power packs instead of TR100 that give you the status relay outputs for monitoring purposes and override on or override off through the building management system. Another point that came up that I can just bring it up, but we can't address it on a webinar, is emergency lighting requirements. The reason we don't go into such details in this webinar is that, one, it's not part of IECC, it falls under another code, and also because it's a matter of emergency lighting and safety issues, I don't want to go into, I don't want to create a general rule about it. And I would rather, you know, we work on it on a one-on-one basis. So if you want to know how the controls, our solution works with emergency lighting and all that, feel free to get in touch with us through phone or email, and we'll work on that specific applications. But I would rather not make general statements on emergency lighting and such things in this webinar.
Okay, well, I haven't gotten any other questions. So if anyone would like any further communication, obviously Logan's information is right there. And you can always email sales or tech support as well, or Logan directly. So with that, thank you very much for your attendance, and have a great rest of your week.
Thank you, everyone.